We are Backend Android developer groups, and today we are presenting in English because our colleague is Krzysztof. He will make the presentation in English. So let's do it. I think that language. So well, you may know our group as we are making, or we are trying to make one event every month about Android, of course. And well, this is the comment. I don't know how it works. And well, the hashtag for today is security basics. So please, if you want, you can make pictures, tagging this Twitter, wherever. And well, this event is sponsored by eDreams, thanks to Andres, who is the guy managing this. And well, is who will provide us pizza and beer after that. And well, without more delay, here's Krzysztof, ready to present us our security basics work. So, please.
Okay, hello, I'm Christopher. In Spanish it's Cristobal. I'm from Poland, but I live in Barcelona and I work in my taxi. And today I would like to talk to you about the Android app security basics. So, who of you are Android developers and doing apps or libraries? Okay, so that's stuff for you. So I divided the talk into two sections. One section is how to keep app users secure, how to protect their data and some private information. And the second topic is how to keep the app secure itself. Let's say that you have some business logic inside. You may have some API that you want to protect out from the hackers, and this is the second section of the talk. Also, I have this talk has form of series of tips that you can apply to your apps, and I divided those tips into two sections. One marked with yellow Android, which are tips that can be hacked like on moderate way, but it's still good to apply them to your app to increase the security a little bit. And the ones with green Android that indicate that those tips are like quite useful and quite safe to use. So the basics. You have an APK, you deliver it to Google Play Store, the user downloads it, and then it gets access actually to all the APK file, all the contents of the APK file on his device. So he can easily browse through the code that you created. Even though you use ProGuard, it's easy to see it. If your app is using shared preferences, the database, it can be viewed by the attacker. So the security of mobile app is more like the phone that enables you to dial 911, but it's wrapped with some metal cover, which can be taken off. And also, when you decompile your app, even though you use ProGuard, if you decompile, it's often decompiled into Smiley format, which is basically an assembler for Dalby. For some of you, it can be like cryptic language that is hard to understand, but there are people who worked in assembler previously or tend to learn it, so it's easy to just see the content of the Smiley file and see what is happening in your code. Moreover, it can be easily modified by some attacker to bypass some security. So why does user security matter? First of all, you would like to make hacker life harder. Then you don't want to lose app reputation. If your app would reveal some very easy, like reveal some leaks that could be easily fixed, you can lose app reputation. Or even in some countries, you as a developer or your company can get sued by some people that when your app reveals some private, like their data, for instance. So most of you, I hope so, know ProGuard. How many of you? 50-50. For those of you who don't know it, I recommend checking it because it's one of the most common solutions to obfuscate the code inside your app. But in this talk, I won't concentrate on that because it's widely covered in the intranet. But
in Android Studio 3, there are tools to help with that.
Yeah, also, yeah, exactly. In Android Studio, you have some tools that show which code was obfuscated or shrinked. So I recommend reading about that. But in this talk, I would like to concentrate beyond that. What are other solutions to protect your app? And in this example, how to protect your database or your shared preferences. So actually, there is one solution for database. It's called SQL Cipher, and this tool allows you to encrypt your database, and then from the perspective of Java code, you're just using it as a normal database. So basically, you load some libraries, and then you get access to database. And you need to provide a secret. Then you can encrypt the shared preferences using another library on GitHub. And this library basically encrypts the keys and the values of their shared preferences. And the usage is also very straightforward. You just need to create a secure preferences object and provide a password. As you may deduct, those two passwords can be viewed by the attacker. So even though you have the database encrypted or preferences encrypted, the password is here. So your objective would be to hide this password somewhere inside your app. But more on that later. So as I said before, encryption on user device with a key that needs to be provided somehow is more like obfuscation. You're just hiding the data using some libraries that encrypt them, but it's more like obfuscation. It just raises the bar for the attacker, so he or she doesn't see your plain preferences or database. Then you should consider deleting user files after he or she logouts. Consider you have an app which has some images, preferences, data. After logout, you should consider removing all this data when the user logs out. So you won't leave anything behind you. Then, pretty basic topic, lots of so when you have an activity, content provider, broadcast receiver, you should make it exported false. That by that it means that it won't be accessed by other application in the system. This check is enabled by default in Android Studio. So when you see your activity in manifest, you get some warning that by default your activity is exported. That means that every single application on user system can access that component. So if you don't plan to like use it from outside your app, you should consider to set exported flag to false. And if you set it to true, you should test your activity as someone who is trying to do something naughty to your app, like stealing some data or making some calls or things like that. One of the oldest tips is to use char array instead of string for passwords, for storing the password. This is because the string object is immutable and can stay longer in memory. And if you use a char array and after the use you fill it with zeros, the data is clear just after the use. But it has like yellow Android because if someone has access to your heap, then he has a lot. It means that even though you use this technique, he can grab your password otherwise. Then, when you see, when you type your PIN in ATM, you often hide your keypad. So equivalent of that on Android is a flag secure. This flag basically prevents doing a screenshot and screen recording on your activity. So if you have an activity that is that you consider very private and you are not willing to being recorded, I don't know, some credit card details or things like that, you should, in your activity, you should get a window object and set flag and set flags to secure. Unfortunately, this has some limitations because, as you can see, underneath there is an activity, but all the overlay windows are visible. So even though the main content of activity is hidden from the recording, all the widgets by the system are visible. So either you need to redesign your UI or use some your custom components that will use these flags secure for themselves. More on the topic on the link. This topic was throughoutly researched by a guy called Mark Murphy, known as Commons Guy. I know him on Stack Overflow. He's quite a known person. Second thing, quite similar, but on newer Android, is Autofill. So you have some fields that can be autofilled, and this is a nice feature, but it imposes some risk because someone can write a malicious autofill provider, which is a kind of service that responds to the user input. So when the user types in, the autofill provider service listens to that input and decides whether this service has some data to provide to autofill. But malicious one can just sniff all the input that is being typed by the user. So there is a way to disable that. You can do it in XML by setting it, setting the file attribute important for autofill to know, or in the code. So by doing that, we are just disabling the autofill from that view. And SSL Pinning. Basically, you should use SSL for secure connection to your backend, and this is like essential. But the basic thing is that you should also consider some kind of pinning. A pinning means that you are not trusting like every SSL certificate in the world. You are just saying that for that domain, you are trusting this particular certificate or this particular group of certificates. And from Android N+, it's quite straightforward. So basically, you need to specify in your manifest link to XML file with a definition of which sites do you trust and how. And this example file looks like that. In this example, we are saying that basically we are trusting the system certificates and the user's certificates. But for our sensitive domain, we are trusting only the system certificates. So we don't trust certificates that can be installed by the user, or user can be tricked to install some root certificate on his device. But this works for Android and above, but there are some backports. So here is a backport for this functionality. So you can use the same file as like standard one and provide a backport compatibility for all the versions of Android. Okay, so this is like tips for user security, and now I will focus on app security. So why you should consider, first of all, you should protect your business logic. If you have some business logic that you don't want to expose, some like algorithm or things like that. And the second is protecting your API. Even though you are using that API inside your app, you should consider that someone can sniff the traffic from your app and use that API to exploit your backend somehow. So what can you do? First of all, you can move sensitive logic to native code, but it's more like security by obscurity. You just moving the code, transferring the code from Java into C, C++, whatever, and hoping that people will be too lazy to decompile the native code. Better way would be considering moving your sensitive logic to the backend. So you just move it to the backend and expose some endpoints, APIs to use from the application. Another tip would be moving development activities to separate Gradle files. For instance, you may have some develop activity that you are using during the development, or QA guys need to set some values, or you have some configurations. And I've seen a lot of examples, lots of applications that doesn't make use of Gradle flavors, and they all put those activities and like configurations, sensitive configuration that is intended for like development process in the production code. Also, as I mentioned before, you have some secrets using for, I don't know, database like SQL Cipher or just preferences. Also, you can have API keys that you are using to access your API. You should consider encrypting them, and for that I recommend using the DEX card, which is a commercial version of ProGuard. Actually, it's done by the same people, and this tool has ability to encrypt some files, especially strings. So even though you have like an unencrypted string, you can encrypt it so it won't be easily visible from the source code. But even though you implemented the SSL pinning, someone can just grab your application, change the network security config, recompile it again, and sniff all the traffic, and your API keys will be visible inside the traffic because you need to use them. So it's more like security by security also. What you can do inside your application to protect from the hackers? You can verify your signature. For instance, you can query the package manager and get the signature of your application. And then when you have your signature, you can compare it to some constant that you bundle inside your application. And then you can see if someone has decompiled your app, modified some code, and because of doing that, the signature of the application has changed. Also, you should consider checking the signatures of apps we are communicating with. So if you have let's say that you have a payment SDK and you are communicating with bank applications, you should, before sending an intent to them to send some data, you should verify the signature of those applications. You should check whether you are talking to legitimate versions of those applications. Then you should consider preventing intent hijacking. Consider you have an activity for changing the password. So and this activity can be launched using a deep link. So you register your activity, you create some schema, some URL that you will be listening, and the flow is that the user gets an SMS or email, clicks on the link, your application appears with the screen to change your password, but some malicious application can also listen to the same URL. So you should consider using app verification. This enables your application to be linked to specific domain, actually your domain. So whenever the user clicks link, he will be directly moved to your application without application chooser. So by doing that, you are preventing it because the other application that register to the same URL, they will won't get the chance to appear for the user. Also, you should consider using explicit intent instead of URL. You may use like normal intent. Then you should use permission checks for your activity, and you can also take advantage of signature checks. So checking whether this is like legitimate app that you are trying to communicate with. Actually, I recommend app verification because it's most straightforward and easy way to do that. Also, you can verify from which source your app was installed. So you can query package manager and get a package name of the installer. And if this string contains com Android vending, it means that your app was installed from the Google Play. Then you can check whether your application has debug flag enabled. So if you publish an application on Google Play and it has debug flag enabled, this means that something wrong is happening because you publish like production version. Then you can check if you are running inside the emulator. You might want to prevent that, and in order to do that, you can check build constants. Then you can also do some root checking, like iterating through some known files and trying to open them and see whether this is possible. It may indicate that you are running on a rooted phone. But all those things are like, all those security measures are like that. You probably live in Barcelona and you know how long this would last. Of course, if the thief is stupid enough, he can cut this red log because it's easy to cut. So basically, you should consider verifying your application using Backend. So whenever your signature of your app change, or you will detect some rooted phone, but not inside your app, but using some backend techniques, then you can move your security of your application a whole lot higher, on a higher level than that. But these topics will be covered in a month in a second part of this talk. So, do you have any questions?
Just another comment. App verification needs marshmallow at least, if I'm not wrong.
App verification
requires. You mean the using the manifest?
Yeah. Actually, to use app verification, you need to put some file on your server that will indicate that only your application with your signature can open links defined by it. So yeah, it needs some job on the backend side. Yeah.
No, it also needs Android Marshmallow.
Yes, that's true. Yes.
Yeah. You said that a malicious application can pretend to be a legit application that well, you're supposed to check the signature of this application you are communicating with that. it wouldn't it be easy to change the signature for another malicious application that you have used?
Actually, the scenario is that you should use the signature check if you have like your application that communicates with another application. So you're hoping that the attacker is not playing with has not access to the phone. He cannot root this, but you're considering like normal user that is that had installed your application, or you are developing some SDK, and there is another app on the device that registers some intents or was downloaded from not from Google Play, and in that case you should considering checking the signatures of that other app. Sorry?
If we're not good, for example, with the Encrypt Emulator, I think that by default it's your root. For example, let's say to have an X or to, for example, to access some files from RIA, from database, or from file preference, for example.
You mean when you are using the emulator?
When you use emulator, you are root.
Yes.
But if you use a password, you have another root. It's possible any way to transfer the data from the smartphone to emulator to extract the information?
The question was, is possible to transfer data from the device to emulator?
So,
Actually, I haven't seen any solution. Maybe there is, but
there is one thing of this, it's a good point. Is in the case you need to secure your information, one thing you can do is to disable backups. So your application cannot be backed up, and because using API you can do a full backup of your application into your desktop and then unpack it. I think they added something, I don't know if it's in Marshmallow or N or something to make this harder, but there is also a flag in the manifest to instruct the operating system to not allow it.
yeah, because actually in the newer version of Android, you can specify that you want to perform a backup. So all your preferences and data will be backup on Google server for like transferring from one device to another. I think that limit is up to 20 megabytes, and this is one thing. So you shouldn't considering backupping like the huge files. And the other thing is that you can disable it in manifest, not allow users to have a backup of some important files like shared preferences or database.
Should you consider Encrypt shared preference, or if it's not mandatory because only you can access it?
It depends on the use case, whether you should encrypt the preferences or not. If you are storing only some preferences, like which tab should be displayed, or which like this irrelevant information from the security perspective, then I won't consider securing this. But for instance, if you are using the shared preferences for storing the API keys, for instance, then I would do it.
So what's the most secure thing how to save the password for these shared preferences? For example, if you think or if you can count that the application can be used on the rotation forward.
Actually, I won't say that there is any secure way, because in some point of time you need to have those preferences or database encrypted. So you need to get the key from somewhere, and you need to use that key to decrypt the database or preferences. So there is no way. I would recommend just if you have like banking application and you would like to store a PIN for that, I would store it in the backend. So I wouldn't allow users to use the app while offline. So storing that data in the backend.
In Android N, I think. It's something I read, but I haven't tried it yet. They added the APIs for the fingerprint, and they can use hardware elements to store this kind of data.
Yeah, but still,
it depends. Yeah, it depends on hardware.
Yeah, so the hardware also can be compromised somehow. So
it only works on new Androids, right? Like I think that on iOS there's some kind of the thing that you can save the password or something on hardware, but here the Android.
yeah, the fingerprint on newer version, yeah. But actually, this thing is quite promising. I mean, safety net, and I will cover that topic in a month. But if you are looking for a way to check your app for rooting and checking your signature of your app, it's the best way to go. Okay.
For storing password, what about using keychain and TikTok that provide Android for encryption?
Sorry?
Android provides a keychain and TikTok to generate private keys and use that for encryption. What do you think about this?
Yes, but then, as I mentioned before, you need to use that key to decrypt the preferences and the database. So even though this key can be hijacked in some point of time. So this is the main problem of protecting.
I mean, for example, this key story is what using Android to store, for example, access key for the API, like access token that you Google API, it is in transfer, for example, called system 8. Then that means also when you have your phone, also Gmail or any app that uses like Google API, the access token is not secure. Because I just started because I mean, if you are rooted, you are lost. So if you are rooted, you have access to anything, then I discard it. If you root your phone, then you should be knowing what he's doing. But I'm talking about normal use.
But you mean key for Google APIs or?
For anything, I mean, for store token, password, etc.
Yeah, but
it's emulating what Google.
Yeah, but
key in the same place as Google does.
Yeah, but then this you need to get this key from secure storage,
Yeah,
and yes, and use it somewhere inside your code to decrypt. So this is like
encrypt and decrypt is domain.
Okay, so you mean that may be an option, but I think that I read that there are some compatibility issues from like one Android version to another, but I haven't dig deep into in that topic. I think that Nikolai Elenko on his blog, he covered that topic. There is one security researcher, I don't remember, he's from Russia or Ukraine, and he was writing about some encryption using the hardware storage, but he pointed out some inconsistencies between Android versions. But if you are interested in that topic, sorry?
Have you published something?
Yeah. After Q&A, I can show you the blog. Okay. And
I have a question about the signature of the app. You have to verify that if the code that you're running is the app that you loaded to the wallpaper, for example. You have to obtain the signature by compiling the app and getting the signature out.
yeah.
When you have to introduce this signature into the code has actually changed. So when you calculate the signature,
No. The signature this is the signature of the certificate that you are using to sign your app. So when you publish application, you will get you need to have some signature of your certificate. So that's the one. So it doesn't change when you change the code.
No, I thought now Google is offering the online signature
Yes.
on Google Play.
Yes.
Have you tried it? Because maybe getting this, I don't know how this would work with online signature.
The same.
I know, because you
Yes.
have to upload it.
Yes.
And then,
The question was because there is an option to upload your certificate to Google. It was announced on Google last Google I/O, but this method will still work because the app gets signed with the same certificate, but it is done on the backend side by Google. But the whole architecture and the whole concept will remain the same. Okay. Anything? Well, no? Then thank you.
So, well, now it's the networking time. We're waiting for pizza and beer. I don't know when will them arrive.
waiting for beer? Really?
Waiting for pizza, and we have beer. You don't need to wait for beer. But they, so, well, I don't know how long they will last, but they are right now. So, we are bringing beer right now. That's it.
Sí, pues.